direct check and their command is complete.
And a decade later, NASA's flagship Magellan was deployed from the space shuttle on an unusually long 15-month journey inward to Venus.
Okay, Pierre, we copy. Pick up.
Looping pole to pole more than 4,000 times, Magellan's imaging radar mapped more than 97% of Venus's landforms. Among Magellan's findings, the volcanic surface of Venus overlies a surprisingly thick crust. Remarkably, about 3 billion years ago, Venus was probably much more like Earth. Each one nurtured the promise of life.
They're the same size, they formed in roughly the same place. There's a lot of circumstantial evidence that Venus had a more Earth-like environment when it was young, so they may have both had warm oceans and all the other conditions necessary for an origin of life at the time when Earth apparently had an origin of life.
Our biggest problem with Venus is that we have so little information about its ancient past. The surface of a planet, and to some extent the atmosphere of a planet, are like a crime scene. Venus is the worst crime scene imaginable because it's been almost completely disrupted over time. And the big question for those of us who are trying to study Venus and understand its history is, when did Venus's evolution really diverge from Earth's evolution?
Venus and Earth are the twin planets. It's the only planet that is likely to be still geologically active in some of the same ways as the Earth. It's really a huge laboratory for understanding the Earth because of its many similarities as well as some differences.
So Venus is kind of the Earth's evil twin sister. It shows how two worlds of similar size, similar density, not that far apart in terms of distance to the Sun, evolved very differently.
Early on, Venus was on a path similar to its sister planet Earth. The radar data hold intriguing clues to a watery past, including vast plateaus made up of granite rocks that likely formed at the bottom of an ocean.
There are areas on Venus that look like continents. They're high standing, they're kind of wrinkly. They are also the oldest rocks on Venus because Venus has had this weird history where much of the surface is new. So these rocks are the only rocks from the first 80% of the history of Venus. That's where we want to go. That's where I want to go, is to these areas which are called tessera terrain because of their tile-like appearance. Whatever it is that spurred the formation of life, in my mind, why wouldn't it have happened everywhere? And that's the record that we're looking for in the rocks of the tessera. Were there evidence of ancient environments that would support life?
Venus is close to Earth in size, mass, and rocky composition. But that's where the similarities end.
Now, one thing we've learned in general about the formation of the planets is that the final stages of planetary formation were characterized by a small number of really huge collisions. Those last few violent collisions happened on Earth in just such a way as to leave it with a moon, and on Venus, through a different combination of impact size and impact angles, it may have had been left with no moon, but with its very slow rotation.
Compared to our 24-hour day, it takes more than 243 Earth days for Venus to rotate just once, the longest day in the solar system.
And it rotates in the opposite direction, so that if you were on the surface of Venus and could see the sun, it would rise in the west and set in the east. You know, on Earth, the sun moves along in the sunrise at hundreds of miles per hour. So you have to be up in a jet airplane if you want the sunset to last forever. On Venus, though, it's 4 or 5 miles per hour. So you could kind of walk along at a good clip and keep the sunset going or the sunrise going as long as you wanted. The pace of the planetary rotation is a human walking pace.
Even that slow pace may be winding down.
The very thick atmosphere of Venus is actually being pushed and pushing back from the topography and changing its rotation rate very slowly and very slightly over the decades. And that has been measured by ground-based units and by Magellan and even by Venus Express, the most recent European mission.
Though the surface creeps along without hurry, the clouds move quickly, and their speeds change. The Japanese Akatsuki probe, also known as the Venus Climate Orbiter, recently found that the atmosphere spins much faster than the planet itself, a phenomenon called superrotation. This movement is driven by heat rising continually from the surface. Mysteriously, the planet lacks a key feature that protects Earth and its atmosphere: a strong magnetic field. Without this protective shield, intense ultraviolet rays from the sun split water molecules apart in the high atmosphere. Then the sun's intense stream of charged particles, the solar wind, carries much of the hydrogen away into space.
In the very early solar system, when the sun was not quite as bright as it was now, Venus was much more habitable. But just a little bit of increase in solar brightness kicked off a runaway greenhouse effect, where the oceans evaporated, put water vapor into the atmosphere that increased the greenhouse, and it ran away to become the very hot, very dry planet we see today.
We definitely believe that Venus had much more water at the surface than it does today, potentially a shallow ocean's worth of water. We really have no information about when that water was lost.
That water could have persisted for billions of years. Billions. And on Earth, life evolved incredibly quickly, actually, considering the meteorites that were hitting the Earth. So why not Venus? And if the answer is it didn't happen on Venus, that tells us something too.
As Venus lost its water, its atmosphere gave way to the noxious outpourings of volcanoes, the primary source of carbon dioxide. But Venus lost its ability to recapture that carbon, trapping itself in a terrifying loop.
Ultimately, the oceans boiled off, partly because of the greenhouse property of water vapor itself, leading to this positive feedback where the more water that evaporates, the more the planet heats up because of the greenhouse effect of the water vapor. And then once the oceans boil off and Venus loses its oceans, then that destroys the carbon cycle, because you still have CO2 coming out of volcanoes on Venus, but there's no way to remove that CO2. The sink disappeared when the water disappeared. And then the thermostat sort of gets pegged in the red zone because you're just adding more and more CO2 to the atmosphere from volcanoes, and it can't lose it anymore without that mediating effect of water, and it ends up in that runaway greenhouse state.